In this video, we are going to review how to graph equations that are in standard form. Standard form, of course, being ax squared plus bx plus c. So if you're just given a quadratic equation in that standard form, how would we go about graphing it? So I'm going to go over how to find y-intercepts and x-intercepts, your line of symmetry, and your vertex. And then all those things are going to help us to graph the equation on these axes over here. Okay. So first thing we want to do, and I highly recommend having, a lot of scratch paper available to you when you do this process because there are just lots of steps, and the more organized you can be, the better. So I'm going to make sure that I label everything really well when I go through this process myself. Okay, first thing I am going to do is find our y-intercept. Now, some of these steps you can do out of order. You don't have to follow me exactly, but some of these, it does make more sense to do it in the order that I give you. So I'll point those things out. This is one of those things, it doesn't matter if you do it now or later, but I'm just going to get it out of the way and do it right now. Okay, so when you're finding a y-intercept, remember that that's going to be when you have your graph crossing the y-axis. And so your x value is always equal to 0. That's key. So I make a note to myself that x equals 0 here. All right, so essentially what that is going to look like is take the value x equals 0 and plug it into your equation and solve it from there. All right, so it would look something like y equals 0 squared plus 2 times 0 minus 8. Okay, well, I know that anything that has a 0 in it just essentially drops off. So I get 0 plus 0, or how about 0 minus 8, and that tells me that my y-intercept is just negative 8. Now, you might be wondering like, hey, that was pretty easy. Is it going to work every time? And the answer is yes. So if you have your plus c value at the end, that constant term, that actually always winds up being your y-intercept, simply because when you plug in 0 for every x, those ones just become 0, and you're left with the constant at the end here as being your y-intercept. So my y-intercept is something like 0, negative 8. All right, so we'll keep that on the back burner for now. Next thing I'm going to do is find my x-intercepts. Now, these steps that come next, I encourage you to do in the order that I give you. All right, so if I'm going to look for x-intercepts, that is actually when y is equal to 0, right? And we've been learning a lot about how to solve quadratics, so I'm going to kind of rush this process a little bit for sake of time. We already have a video using box and diamond method for solving. So, if you're not quite sure what I'm doing, then go back to that video and see that. Okay, so I'm looking for when is my quadratic equal to 0? When is my y value 0? And if I factor this, essentially I'm looking for numbers that multiply to negative 8, but they add up to positive 2. And so those factors are going to look something like, x plus 4? And x minus 2, something like that. Okay, so using zero product property, I know that my solutions are going to be values that make each factor equal to 0. Here, that number would be negative 4, because negative 4 plus 4 is 0. And over here, the x value has to be positive 2, since 2 minus 2 is 0. That would be my, solution set using set notation, but because these are x-intercepts and I care about that, I'm going to go ahead and write them as x-intercepts. So it's going to look like negative 4, 0, and 2, 0. All right, so at this point, I find it really helpful to move over to the graph and take a look at some of these features. So my y-intercept is down here at negative 8, so 6, 7, 8. And my x-intercepts exist at negative 4, so 1, 2, 3, 4, and positive 2 right here. Okay, so the next thing we're going to find, and here's why I recommend doing this in order, the next thing we're going to find is our line of symmetry. So parabolas, of course, make this kind of U shape, and they're really symmetric, right? So if I drew a line straight down the middle, it'd be like mirrored on both sides of that line. That's what your line of symmetry is. So your line of symmetry is always going to exist exactly in between the x-intercepts. So to find our line, I'm going to use red, just be consistent. So our line of symmetry, LOS, is exactly between the x-intercepts, which really is a matter of like taking the average of your x-intercepts. So if I were to take the average, and right now I'm going to, essentially take -4 plus 2 and divide by 2. Like that's how you take the average of two numbers. That puts us smack dab in the middle of those two x-intercepts. So -4 plus the 2 is -2, divide by 2, and I get the value -1. And you can kind of tell, if we draw our line of symmetry here, that this is correct, because check it out. It's 1, 2, 3 away from this x-intercept, and it's also 1, 2, 3 away from that x-intercept. So it actually is exactly in the middle. All right. Now, if you recall, one of the cool things that lies on our line of symmetry is the vertex of the parabola. So now we're going to find the vertex. So notice how all these steps kind of run together. The h value of your vertex, remember that your vertex is kind of h comma k, like that. So the x value, the h in your vertex, is the same as your line of symmetry. So you can call this -4 plus 2 over 2 and get -1. But we kind of already did that, so I'm not going to spend a lot of time there. And then if you want to find the k value, well, that's just a matter of taking your -1 and plugging it back into your equation and kind of seeing, okay, what is the y value that goes with that x value? So let's go ahead and do that. We take -1 squared plus 2 times -1 minus 8. So notice I went back to the original equation up here, and I plugged in -1 for all the x's, and now I'm just going to evaluate. So this becomes 1 minus 2 minus 8. And that should give us what, -9? Okay, so our vertex is the point -1 comma -9 like this. All right, so on my line of symmetry, the x value and line of symmetry are the same. -9 is where my vertex would exist. And then essentially I can just, I'm ready to draw, really. If I want, I can mirror this point to the other side of my vertex. Yeah, to the other side of the line of symmetry, because I know every point gets reflected back and forth. So it's kind of nice to take your y-intercept and reflect it to the other side and just give yourself that extra leading point. Okay, as smoothly as you can now, we will draw the parabola. Must go nicely through the points we've placed for ourselves, up through that x-intercept like this. And then this guy again, kind of trailing right through that mirrored point and up that way. Okay, so there's our process for graphing using standard form. Notice how we started with our y-intercept, built into our x-intercepts. This kind of gave us a platform to go into our line of symmetry, right? Once we knew our x-intercepts, we knew that right in between them would be our line of symmetry, so we took an average of those values. And since the vertex lies on the line of symmetry, we know the x value is -1 also. Plug that in, get your y value, and you're really done. So that's how you can take a graph, an equation from standard form, and get it really specific on your graph.